Hello everyone. So this is the fifth class of indefinite integration standard forms and theorems with proof. So we are going to begin with what we have left in the last class. In the last class, what we have done towards in the three theorems, three standard forms that we studied, where one was 1 upon x square plus a square, the other one was uh, 1 upon x square minus a square, and the third one was 1 upon a square minus x square. Okay, let me share you the screen with you. Correct. So this is something we have done the last form. So in the last class we studied about 1 upon x square plus a square. इसके मैंने दो तरीके बता दिए आपको प्रूव करने के लिए. And the answer is 1 upon a tan inverse of x square x upon a plus c. Second was 1 upon x square minus a square. That answer is 1 upon 2a log of x minus a upon x plus a plus c. And the third one is 1 upon a square minus x square. And the answer is 1 upon 2a log of a plus x upon a minus x plus c. Right? So these were the three standard forms. अब इसके ही एक्सटेंशंस अभी दो टाइप के सेट्स हम लोग करने वाले हैं. रादर देयर आर थ्री सेट्स. दिस वाज द फर्स्ट सेट. द सेकंड सेट that I'm going to start right now is number 1. Let I equal to 1 upon root of a square minus x square dx. Okay, now again this comes from standard substitution that we have studied in derivatives. The same substitutions continues. If there is a square minus x square, what we do is put x is equal to either a sine theta or a cos theta, but maximum number of cases we consider it as a sine theta. So if I take a derivative, x ka derivative 1 dx, and a cos theta derivative is sine theta derivative is cos theta d theta. Okay, now because of this also indicates number 1, sine theta is equal to x upon a, and theta is equal to sine inverse of x upon a. Correct. Now इसकी जरूरत अपने को एंड में लगने वाली है. Let's see how. Now I is equal to integration 1 upon, oh I'm so sorry, not 1 upon, what is 1 dx? Dx is a cos theta d theta divided by a square minus what is x? X is a sine theta whole square. Now that is equal to a cos theta upon under root a square minus a sine theta whole square is a square sine square theta d theta. Right. Now that is equal to a cos theta upon, here if I take a square common, inside the bracket it will be 1 minus sine square theta d theta. Right. Now I is equal to a cos theta divided by a square 1 minus sine square theta is cos square theta d theta. So this becomes a cos theta upon इसका root a cos theta, once again d theta. Now a cos theta upon a cos theta, complete thing gets cancelled. Now that means I is equal to integration 1 d theta. So when it is integration of 1 with respect to x, we write x. So यहाँ पे I is equal to theta plus c. राइट. नो व्हाट इज द वैल्यू ऑफ थीटा? हमने पहले ही निकाल के रखा है. यहाँ पे थीटा का वैल्यू कितना है? साइन इनवर्स x अपॉन a प्लस c. हेंस माय फर्स्ट इंटीग्रेशन यहाँ पे है 1 अपॉन रूट ऑफ a स्क्वायर माइनस एक्स स्क्वायर इज इक्वल टू साइन इनवर्स x अपॉन a plus c. This is the first one of this class. Remember, हमने 3 का एक सेट पहले किया था. 1 अपॉन एक्स स्क्वायर प्लस ए स्क्वायर, 1 अपॉन एक्स स्क्वायर माइनस ए स्क्वायर एंड 1 अपॉन ए स्क्वायर माइनस एक्स स्क्वायर. दिस इज 1 अपॉन रूट ऑफ ए स्क्वायर माइनस एक्स स्क्वायर. That is the difference. The next one in this series is let I equal to. Now this is a very this is going to be very interesting for us. The integration of 1 upon root of x square minus a square. All right. Now, as usual, again, I'm saying कि this हम यहाँ पे कुछ दिमाग नहीं चला रहे. These are the standard substitutions that we learned in derivatives. So यहाँ पे क्या करेंगे हम? I'm going to put x is equal to a sec theta. Right? Whenever it is x square minus a square, it is a sec theta. That means dx का value जो है a sec theta tan theta, because sec theta का जो value है, sec theta का जो derivative है, that is sec theta tan theta d theta. Also because x is equal to a sec theta का value क्या बनेगा? Sec theta का value बनेगा x upon a. राइट. इसकी शायद जरूरत नहीं पड़ेगी इस प्रॉब्लम में, बट यहाँ पे लिख देता हूँ. आदत डालना है अपने को इसीलिए, बट इसकी जरूरत नहीं पड़ने वाली है. ऑलराइट. नाउ लेट्स कम बैक टू द क्वेश्चन. I is equal to, ओके, रिमेंबर इसकी जरूरत नहीं पड़ने वाली है, बट देन स्टिल इट इज जस्ट अ पार्ट. हम लोग यहाँ पे लिखने की आदत डाल रहे हैं. ओके. नाउ I is equal to dx क्या है? a sec theta tan theta d theta डिवाइडेड बाय x की वैल्यू क्या है? a sec theta होल स्क्वायर माइनस a स्क्वायर. Now that is equal to a sec theta tan theta, the whole thing divided by under root a square sec square theta minus a square d theta. Now I is equal to, once again, a sec theta tan theta divided by, if I take a square common, inside the bracket is sec square theta minus 1. Now, as we all know that the second identity in trigonometry is 1 plus tan square theta is equal to sec square theta. That means sec square theta minus 1 is always equal to tan square theta. That is equal to sec square theta minus 1. Okay. Now, I is equal to integration a sec theta tan theta divided by under root a square tan square theta, right, d theta. I forgot to write here also. Okay. Now, I is equal to integration a sec theta tan theta divided by a tan theta. Now what happens here, unlike the previous case, यहाँ पे a gets cancelled, tan theta and tan theta gets cancelled. Right. Now what remains is I is sec theta d theta. All right. Now, we all know integration standard form. We have studied in the second class that sec theta ka integration is log of sec theta plus tan theta and plus c. ओके मैं यहाँ पे C1 लेता हूँ, थोड़ी देर में आपको पता चलेगा why I'm taking it as C1. Now, very interesting part about this question. Now, if you observe, we know the value of sec theta, correct? यहाँ पे अपने को sec theta का वैल्यू दिख रहा है. कहाँ दिख रहा है? यहाँ पे हमने sec theta का वैल्यू निकाला है. Sec theta is equal to x upon a, right? What about tan theta? Now, tan theta के वैल्यू निकालने के दो तरीके हैं. Okay, once again tan theta का वैल्यू निकालने के दो तरीके हैं. वन ऑफ द मेथड इज यहाँ पे देखो हमने करके रखा है tan theta. We know that now tan square theta is equal to sec square theta minus 1. That means sec theta का जो वैल्यू है x upon a whole square minus 1. Okay, now coming back here, मैं यहाँ लिख देता हूँ tan square theta becomes x square upon a square minus 1. That means tan square theta is x square minus a square divided by a square. This is one of the way जहाँ पे दिमाग लगाने की जरूरत नहीं है. I think this will be fine for you. Hence, I am not showing the second method. Tan theta is equal to under root x square minus a square. So we are taking the root divided by, here it will be a. Okay, let's rebuild the problem now. Now here the answer is log of sec theta plus tan theta. Log of sec theta. But what is sec theta? Sec theta is, you can see, x upon a. यहाँ पे हमने करके रखा है sec theta is x upon a. And just now we found out that value of tan theta. Tan theta का value है under root x square minus a square divided by a. Right? मैंने plus c1 लिखा था. Let us discuss plus c1 क्यों लिखा हुआ है. Let me work on this. Okay, so I is equal to log of, this is x plus root of x square minus a square divided by a plus c1, correct? Now, according to the law of logarithm, laws of logarithm, ये जो part है ना, this part, what is log m upon log n? Log m upon n is log m minus log n. All right. Now, hence, this will become I log of x plus root of x square minus a square minus log a plus c1. Now, as we all know that a is a constant. Okay, so a is a constant, hence this can be written as log of x plus root of x square minus a square plus c, where I will say where c is c1 minus log a. Finally, now my new standard form is 1 upon root of x square minus a square dx is equal to log of x plus root of x square minus a square plus c. Now, we have finished with the second standard form. The first one was, this kind was 1 upon root of a square minus x square. Listen to me very carefully. It was 1 upon a square minus x square, and the integration is sine inverse of x upon a plus c. The second one is 1 upon root of x square minus a square, and the integration is log of x plus root of x square minus a square plus c. Let's move on to the third part now. All right, third part is कौन बचा अभी? a square minus x square हो गया. We finished with a square minus x square. We finished with x square minus a square. Now the last one that remains is x square plus a square dx. As usual, again, we have studied this in derivatives, standard substitution. So I'll be making some standard substitution. I'm using some standard substitution. Put x is equal to a tan theta. Correct? Now that means dx is equal to a sec square theta d theta. Dx is a sec square theta d theta. Also, as I will be requiring this, tan theta का value है x upon a. Alright. Now, coming back to the problem, I is equal to integration a sec square theta d theta. ये है मेरे dx की value divided by root of a tan theta whole square plus a square. Now that is equal to a sec square theta upon a square tan square theta plus a square. Okay, I'm expanding that. A tan theta का whole square consider किया मैंने. Now that is equal to a sec square theta divided by, I take a square common and I get tan square theta plus 1. Okay, d theta. Now that is equal to a sec square theta divided by, as we all know, 1 plus tan square theta is sec square theta. So this becomes 1 upon root of a square sec square theta under root. Correct? Now I is equal to a sec square theta divided by, डिनोमिनेटर में ए स्क्वायर सेक स्क्वायर थीटा का रूट, एक स्क्वायर का रूट ए हो गया, सेक स्क्वायर थीटा का रूट सेक थीटा हो गया डी थीटा. नाउ व्हाट हैपेंस इज इन दिस a and a gets cancelled, one sec theta gets cancelled. So finally I have integration of sec theta. Just like the previous one, we all know that sec theta का integration है log of sec theta plus tan theta, and again plus c1. Just like the previous problem, we know that, see, because ab kya hai, the thing is, we know the value of tan theta, but we do not know the value of sec theta. Here in this case, we know the value of tan theta, that is x upon a, that we do not know the value of sec theta. So 1 plus tan square theta is sec square theta. So that is equal to 1 plus tan theta is x upon a the whole square, and that is equal to 1 plus x square upon a square, and that is equal to a square plus x square divided by a square. All right, let's do this. Sec square theta is this. So what will be sec theta? In this case, sec theta will be root of x square plus a square divided by a square का root a हो जाएगा. All right, now have a look at this. This is your answer, sec theta plus tan theta. All right, now I'll write here now, I is equal to log of sec theta plus tan theta. So what is sec theta? Sec theta is x square plus a square upon a. What is tan theta? Tan theta is x upon a plus c1. Okay, that means the value of I is log of under root x square plus a square plus x upon a plus c1. That means I is equal to log of x plus root of x square plus a square minus log a plus c1. And just like the previous part, I is equal to log of x plus root of x square plus a square plus c, where c is equal to c1 minus log a. All right, so this is the final part. Now that means the last and the third integration standard form is 1 upon root of x square plus a square dx is log of x plus root of x square plus a square plus c. So this was the third in this series. The first one was 1 upon a square minus x square, और उसका इंटीग्रेशन था साइन इनवर्स x upon a plus c. The second one was 1 upon root of a square minus x square, sorry, x square minus a square, and the integration is log of x plus root of x square minus a square plus c. The third one is 1 upon root of x square plus a square, log of integration इसका है log of x plus root of x square plus a square plus c. राइट ना, ये जो पार्ट है स्पेशली ये 1 अपॉन रूट वाला है. सो 1 अपॉन विदाउट रूट जो था, 3 स्टैंडर्ड फॉर्म्स किए थे, यहाँ पे भी 3 खत्म हो गया. बट यहाँ पे देर इज वन मोर एक्स्ट्रा, दैट इज द फोर्थ वन. इन स्पेशली ओनली इन दिस केस इट इज 1 अपॉन x into root of x square minus a square dx. right, as usual standard substitution हमको क्या करना है, put x is equal to a sec theta. जब भी आपको x square minus a square दिखे, आपको ये substitution standard है, x is equal to a sec theta. That means the derivative x का derivative 1 into dx is equal to sec theta का derivative sec theta into tan theta d theta. राइट नाउ वन मोर थिंग, यहाँ पे अगर इसको देखें हम x का वैल्यू, दैट मीन्स ऑल्सो सेक थीटा का वैल्यू हो जाएगा x अपॉन a, एंड थीटा इज इक्वल टू सेक इनवर्स x upon a plus c. Let's begin with the problem. I is equal to integration, यहाँ पे ऊपर तो dx के बदले a sec theta tan theta. Have patience, have focus on the problem. Now this is x का वैल्यू जो है, x का वैल्यू क्या है, a sec theta. राइट, इंस्टेड ऑफ x हमने लिख दिया यहाँ पे, ये x के बदले हमने लिख दिया a sec theta. अगेन x के बदले a sec theta whole square minus a square. All right, now I is equal to यहाँ पे a sec theta tan theta the whole thing divided by a sec theta inside the square root, it will be a square sec square theta minus a square. Okay, I'm taking time, I'm writing, I'm going very in a detailed way. I'm doing this as a sec theta tan theta divided by a, I'm so sorry, a sec theta a square common d theta. All right. Now, let's come back here. I is equal to integration a sec theta tan theta whole thing divided by बाहर a sec theta है. All right. Now, according to the second identity, a square तो यहाँ पे ऐसे ही लिख दिया, this a square. Sec square theta minus 1 is tan square theta d theta. ठीक है. Now, that is equal to integration a sec theta tan theta divided by a sec theta multiplied by, now root of a square is a, root of tan square is tan theta, ये चला गया. Now tan theta gets cancelled, sec theta gets cancelled, 1a gets cancelled. What remains with me is only 1 upon a. Okay, ये मेरे पास सिर्फ इतना ही पार्ट बचा, this part is with me, बाकी सब कैंसिल हो गया. All right, now 1 upon a integration 1 upon say, since it is a constant, I have taken it outside, 1 d theta. So that is equal to 1 upon a, 1 ka integration theta plus c. Already we are aware of the value of theta, that is theta is sec inverse x upon a. So I is 1 upon a sec inverse x upon a plus c. Finally, my final step, integration of 1 upon x into root of x square minus a square dx is a standard form is 1 upon a sec inverse a x upon a plus c. Okay, so this is the last of this series. मतलब ये जो फॉर्मेट है इसका ये लास्ट फोर्थ वन हमने किया. वी आर गोइंग टू कम अप विथ और 3 स्टैंडर्ड फॉर्म होंगे इसी टाइप के, लाइक रूट ऑफ a square minus x square, directly root of a square minus x square. So it will be, the third part will be root of x square minus a square, root of x square plus a square, and root of a square minus x square. Okay, now once again today's standard forms. The first one, okay, you might be thinking कि बार बार क्यों repeat कर रहे हैं. So the best way is to remember is to repeat everything. That is the best way. Ideally write it down and write it down, because paper आपको लिखना है, बोलना नहीं है. You are not supposed, there is no oral exam in this, right? So you're supposed to write everything. So remember, the first one is 1 upon root of a square minus x square. The integration is sine inverse of x upon a plus c. The second one is 1 upon root of x square minus a square. The integration is log of x plus root of x square minus a square plus c. The third one is 1 upon root of x square plus a square, and the integration is 1 upon root of x square plus a square, and the integration is log of x plus root of x square plus a square plus c. And the fourth one, 1 upon x into root of x square minus a square, 1 upon a sec inverse x upon a plus c. Okay, now in the next class we are going to study 2 important theorems. One is about biparts, uska theorem proof. If you just go through the question papers, past papers, right from 1990s से लेके अभी तक के पेपर में देखो, बहुत बार ये u into v, that is integration by parts का theorem पूछ चुके हैं. So we are going to do 2 theorems in the next class, and after that there will be a last class of last set of standard forms, that is integration of root of x square minus a square, integration of root of x square plus a square, and integration of root of a square minus a square. All right, now that's it for today. I think we have covered almost integration. I think there are 2 more classes that I'll be taking. After that, I'll be moving on to vectors and its theorems. all right, because very important thing, vectors में से भी एक theorem exam में आएगा. So we are preparing slowly for ourselves. मतलब 12 to 17 marks theorems will be there, and slowly we'll move on to PYQs and everything. Okay. Bye bye for today. Thank you very much.